Sedna, the story of the trans-Neptunian object, who was a planet for a day. Sedna is not that big of a deal. From the point of view of physical characteristics, it is just one of many trans-Neptunian objects discovered in the past years. Not the smallest, but not the largest either. Over time, its diameter, estimated after discovery at an optimistic 1,800 kilometers, has dropped to half of that, and today it is believed to be similar in size to Ceres, the queen of the main asteroid belt. And so, one would be forgiven for wondering, why deal with it beyond the bare minimum of information owed to any celestial object? As we're about to see, the reasons are there, but we want to leave the final judgment to you. Think about it. We are making so much progress in our knowledge of the universe, in the study of galaxies, millions and billions of light years away, yet we still know very little about the planetary system that hosts us. No one, in fact, can yet answer this simple question: where does our solar system end? By the early 1990s, our celestial cradle seemed to have no more secrets for us Earthlings. The Mariner and Venera probes had unveiled the surfaces of Mercury, Venus and Mars, while the Pioneer and Voyager missions had later succeeded in reaching and photographing the great outer planets as well. Thus, having long since vanished the ghosts chased in the past, such as the intermercurial planet Vulcan and Planet X, in the years that followed, the belief was almost reached that every corner of our cosmic cradle from Mercury to Pluto had already been discovered. One star, 9 planets, many moons, thousands of asteroids, and the occasional comet. What more could there still be to discover? Then, in 1992, came the surprise discovery of the first object orbiting Pluto, soon followed by many other medium-sized asteroids, which spanned 200 to 300 kilometers in diameter. The first real inhabitants of the Kuiper Belt, whose existence until then had only been hypothesized. And it was as if suddenly the solar system doubled in volume. So it really was true. Beyond the orbit of Neptune stretched a belt 10 times larger than that of the asteroids, with a huge number of rocky and icy objects orbiting the Sun at a distance of between 35 and 55 astronomical units. Remember that a so-called astronomical unit is a unit of measurement equal to the Earth-Sun distance, which is about 150 million kilometers. And the digital revolution was also making it possible to get to find fainter and fainter objects. In November 1998, Chaos, a 600-diameter trans-Neptunian 46 astronomical units away, was found. Then, in November 2000, it was the turn of Varuna, 680 kilometers in diameter and 43 astronomical units away. Followed in May 2001 by Ixion, 700 kilometers in diameter and 40 AU away. Then entered onto the scene this staff of Michael Brown, a Caltech astronomer who had set up a revolutionary wide-field search survey with Palomar's Ocean Telescope. It was during that campaign that on the night of November 14, 2003, an object was detected and given the provisional designation of 2003 VB12. From the very first data available, it becomes clear that we are in the presence of something extremely distant. An initial analysis suggests that it may be about 100 AU, but not only that, from the initial cursory assessments, it would be a really large object with a diameter that could approach 2,000 kilometers. The November 14 detections are confirmed by other observers, and thanks to subsequent observations, an attempt is made to speculate on a first possible orbit. But the available data is still too sparse to return sufficiently acceptable results. Indeed, to calculate the characteristics of an orbit, it is necessary to have observations covering a time span of several years. There is a loophole, however, and that is the so-called precovery observations, short for pre-discovery recovery. That is, one hopes that the object, by chance, may have been photographed months or years earlier during some other survey, so as to extend the observational span as much as possible. And that is exactly what happened with 2003 VB12. The object is also identified in Paloma Quest images taken on September 29 and August 30, 2003. The new astrometric data not only allowed a more accurate orbit to be defined, but also to allow the object to be identified on images taken by Paloma Schmidt dating back to October 2002. And fate is even more benevolent. the new dates are able to go back even further, discovering the object's presence on images taken by the Near-Earth Asteroid Tracking Program in September and October 2001. Now the available data are adequate, and the orbit can be defined with sufficient accuracy. Thus, it turns out that at the time of discovery, the object was 90 AU from the Sun, but also that 2003 VB12 traverses a very elliptical, elongated orbit, with a perihelion, the closest point to the Sun, at 76 AU, and the aphelion, the farthest point, as high as 937 AU, or 30 times farther than Neptune. This is an incredibly large orbit, so much so that the object takes a whopping 11,400 years to travel the entire orbit. No other known object discovered beyond Neptune reached such distances, and so suddenly the solar system found itself growing tenfold in size. When the official news of the discovery came in February 2004, it caused a sensation and was interpreted by many as if a new gold rush had opened at that moment, with the Kuiper Belt instead of the Klondike. There was a real belief that very soon very large planets would be found in those regions, and right away the newcomer is being hailed by all the media as the 10th planet in the solar system. Because of its location in those icy regions, the discoverers proposed that 2003 VB12 be assigned the name of Sedna, a deity of the Inuit, the original inhabitants of Arctic regions of North America and Siberia, believed to be the mistress of the deep ocean and mother of all creatures that inhabit the sea. But one question lurked: how could a planet-sized object have such a strange orbit? Indeed, Sedna's celestial path is very different from that which characterizes the objects that populate the Kuiper Belt. Rather, it resembles the orbit of a very long-period comet, one of those icy bodies stationed even further out in the so-called Oort cloud, a spherical region of space surrounding our solar system that would be a kind of reservoir of objects of cometary nature. It is believed that cometary nuclei populating those remote regions may sometimes experience gravitational influences capable of deflecting them to the innermost parts of the solar system. And this may be the case with Sedna. The difference is that this time we are dealing with an object with dimensions unimaginable for a comet. It is also possible to think that Sedna's orbit is the original one. The high eccentricity is a clear sign of heavy dynamical interventions. Not to mention that it would also be very difficult to clarify how such a large amount of material could have aggregated at such a distance from the Sun. Undoubtedly, Sedna had to have been formed elsewhere and then placed on its present orbit by some powerful dynamical mechanism, such as the passing in remote times of a star roughly the size of the Sun at a distance of about 800 AU. According to simulations, such an event could not only have originated in such elongated orbits, but would also have been able to explain the origin of Sedna itself. The hypotheses that, among other things, led to an even more intriguing scenario. In fact, other numerical simulations led to the hazard that the perturbing star might not even have come from outer space, but might be one of the many stars formed with the Sun within a small star cluster. Suggestive hypotheses, but obviously very difficult to prove with so little data available. However, it is not such a strange orbit that has pushed Sedna overwhelmingly into the spotlight. It is its size that interests the general public. The images that had enabled its discovery obviously did not allow very precise assessments of its diameter. One had to rely on apparent luminosity and distance, which were the two known values. But then, one had to make assumptions about the reflectivity of the surface. From a combination of considerations, they are able to estimate a diameter of 1,800 kilometers. So much so that, as we have already seen, they immediately cry out for the 10th planet in the solar system. It was in fact the largest trans-Neptunian object after Pluto. And from there began the long process, unscientific and very political, that would lead to the decision to decay Pluto from planetary status. And we all know how that went. Until the 1800s, there was really no need to give a definition of a planet. The only tenets of the solar system were comets, satellites, and indeed planets, those known since antiquity, to which Uranus and Neptune have been added. A demarcation so obvious that there was really no need to codify it into a definition. Common sense seemed to be more than enough. But then came the discovery of Ceres in 1801. Followed shortly by that of numerous objects confined between Mars and Jupiter. At first, Ceres was there to acquire the title of planet, but within a few years, the number of potential new planets, which we now know to be mere asteroids, began to grow alarmingly. And it was their large number that ruled out the possibility that those large specks of light could all be classified as planets. 2 centuries later, the same thing was repeated in the Kuiper Belt. The discovery of Sedna, first believed much larger than true, and then that of Eris, prompted astronomers to fear that soon the skies would be invaded by dozens of new planets. And so, instead of facing an embarrassing situation, we found it more convenient to downgrade Pluto, then giving it the dwarf planet status. Michael Brown himself, then in recent years, has proposed that the existence of planetoids, as distant and with such elongated orbit as Sedna, could be evidence for the presence of a planetary-sized disruptive body, the famous Planet 9, about which so much has been heard in recent years. Before moving on, be sure to like or dislike the video so that we can continue to improve and make these videos better for you the viewer. Plus, be sure to subscribe to the channel by clicking the bell notification icon so that you don't miss any of our weekly videos. So what do you think? Did Sedna deserve, or does it still deserve, all the attention we're giving it? If your answer is positive, then you will be pleased to know that you are in full agreement of those who are planning a space mission to the planetoid. Sedna will indeed reach perihelion in the biennium 2075 to 2076. It will arrive at the minimum distance from the Sun of 76 AU, and this event will be an opportunity that will not repeat itself until about 11,400 years from now. Reaching Sedna with a spacecraft will not be an easy task. For comparison, Neptune is about 30 AU, and the Voyager missions, launched in 1977, are at these times at 156 and 130 astronomical units respectively. A team of scientists, led by Vladislav Zubko of the Space Research Institute of the Russian Academy of Sciences, thus recently studied several possible trajectories, favoring a launch date of 2029 as the most feasible option. The 2029 trajectory would indeed take the spacecraft first to Venus, then back to Earth twice, before crossing Jupiter on the way to Sedna with a flight duration of 20 to 30 years. A 30-year flight plan would mean flying over Sedna more slowly, allowing more time to collect data on the object. Choosing this option would give the probe a relative speed of 13.7 km per second as it passes Sedna, comparable to the speed at which New Horizons approached Pluto in 2015. And just as Voyager did, which took advantage of Jupiter's buoyancy to accomplish their tour of the solar system, it will take similar gravitational slingshots to make the journey to Sedna manageable. The close study of Sedna, needless to say, would represent a unique opportunity to analyze the most distant celestial body in the solar system and understand whether it developed in the Oort cloud and whether its composition and geophysical properties differ from celestial bodies in the Kuiper Belt. We really hope the mission will happen, even if it will be a long, long wait for its arrival.